All right, guys. This is the Power Review number 3. Power Review 3. And again, some of these items may be repeated from an earlier video. I don't quite remember everything that was put on there because I'm kind of doing this on the fly to help you guys out. But if it repeats, that's great anyway because it'll be good practice for you. First thing I want to draw your attention to is to think about what is a zero. When we're talking about a polynomial function, a zero is a place where you have, a number that creates a zero. In other words, it solves the equation, solves it whenever it's set equal to 0, solves the polynomial function whenever it's set equal to 0. So here's a little example here that's easy to understand. Suppose it was x squared plus 4x plus 3 equal to 0. A solution or a zero be obtained a couple different ways. You could either factor this thing or use the quadratic formula. I suggest whenever at all possible factor. You want to look at your solutions as well. So in this case, you'd have x plus 3 and x plus 1 equal to 0. Those are your factors, but they're not your zeros. Your zeros would be x equal to -3 and -1. Okay, and so again, if you would see this on the test, you just plug the A, B, C, and D choices into the equation here and see which one of those would give you 0. I think I did do this one on another video, so I won't go back through the whole thing. Next thing I want to talk about is, and this is in no particular order, guys, just how I've kind of looked at a couple things as I was just going through some other potential problems. In terms of zeros, this in keeping in line with what a zero is, suppose you had something like this, x to the -4 times x plus 6 times x plus 2 equal to 0. This has already been factored. This is obviously a cubic. All right, here you can tell that it's a cubic because you have 3 zeros, right? I mean 3 x's rather. And so my first zero would be at x equal to 4 and then -6 and then -2. The signs are going to be opposite of what the factors are. And of course, I think I did one like this as well. And this is going to be a positive cubic. So we know how that's supposed to look in terms of, all of the end behaviors of a linear, a cubic, and a quintic all behave the same. So I just kind of get my cue from this dude here, and it's down, up. So you know that it's going to be at what? One of your zeros is going to be at +4. Then you're going to be at -2 and 3, 4, 5, 6, something like that. And then it's going to be down and up. Okay, probably something like this, more or less. Okay. What else do we need to be able to do? Well, you also need to be able to, for instance, if I start you out, let me push this up. You guys couldn't see that, didn't know that. There you go, right there. There's the graph for those. This would be a +4, -6, and -2 right there. There you go. Now, you have to be able to go the other direction as well. Suppose that I just gave you some zeros. If I said, what is the polynomial represented when the zeros are, let's just make up some here, -3, 1, and 4. Just make up something there. What's the polynomial function? If I give you the zeros, do you know how to go back and create the function? Well, it's very simple, guys. If that's the 0, the factor is going to be x plus 3. And another factor, if this is positive 1, it's going to be x subtract 1. And if this is positive 4, this is going to be x subtract 4. All right, now that's the factored form. All of the zeros and the factors are going to be opposite of each other. All right, and then if they gave you an ABCD choice of what the polynomial itself is, then you're going to have to do a little bit of factoring, not factoring. You're going to have to do a little bit of multiplying here. Okay, so what you would have to do is either FOIL or use a box. So I'll go ahead and set this up right quick, but I won't work it all the way out. See, x times x would be x squared. X times negative subtract 1 would be x subtract. Would be subtract x plus 3x subtract 3. Make sure that's right. X squared subtract x plus 3 subtract 3. All right, then you'd get what? X squared plus 2x subtract 3. And in this case, now you have to multiply it by the x subtract 4. And then you'd have to either use a 2 by 3 a box or a 3 by 2 box, wouldn't matter, or you can just FOIL it all out. Just distribute the x squared here, distribute it again, distribute this, distribute here and here. So either way it goes, you got to multiply one more time. And so what I'll do is I'll do this on the next page. Let me just go back through my work here. So yeah, first thing you want to do is take, if I gave you the zeros, you want to change the factors, okay, like so. Then we're going to multiply. We'll get x squared subtract x plus 3x subtract 3. And simplify this part, x squared plus 2x subtract 3. Now I'm going to go to a clean page here and show you the rest of the multiplication. So then you would, I'm just going to use a box. I wrote this thing kind of big, didn't have to really write it that big, but I'll go ahead and since I got it going here, I'll just leave it. I'm going to use a 2 by 3 box, and from the previous problem, you had the x subtract 4 here on that side, and up here you had you put x squared, 2x, and negative 3. It doesn't matter if you use a 2 by 3 or 3 by 2. Then you just go ahead and multiply this stuff out and get x cubed, 2x squared, subtract 3x. Then you're going to get subtract 4x squared, subtract 8x. Plus 12, and then the diagonals here and here will have like terms, so your final answer is x cubed subtract 2x squared subtract 11x plus 12. All right, and that's how you would do it, and then you just pick your answer from there. All right, what else can you expect or look for? All right, guys, picking back up from where we last were. Let's head in a little bit different direction. Let's talk about factoring for a minute here. Factoring. Okay, some of you guys are not very good at factoring. Others of you are. Most of you are probably better at multiplying than factoring. But here is something that I want to talk about right quick that you may run into. For instance, let's talk about the basics here. If you have x squared subtract 36. This is a basic difference of two perfect square, or difference of two perfect squares. So you get x subtract 6 and x plus 6. Okay. Now, what if you ended up with x squared plus 36? All right. When we were dealing with real numbers, we'd say this is prime or can't be factored. It's already simplified. But then as we moved on to one of those chapters, we encountered imaginary numbers, and we discovered that you're going to go through basically the same mechanics here, but you're going to end up with this: x subtract 6i, and then x plus 6i. All right, and that's how you handle that. So you got to remember that if it's addition, you will end up with not plus, it's still plus or minus, but you got to throw that I on there. And if you don't believe this, you just multiply it out and we'll end up right back where we started. See right here, we got x squared. See right here, x squared. And we have plus 6i. and then subtract 6i, and then subtract 6i squared. These two middle terms eliminate themselves, and you have x squared. Subtract 6i squared, but you have supposed to be 36 right there. 36, subtract 36i squared, fix that, 36. All right, and what you have is x squared, subtract 36i, and then there's a -1 here. See, I squared is -1. You got to remember that I squared is -1, so you end up with having x squared plus 36. So you just got to remember that when you're talking about how do you factor something like this. All right, what else can you expect? Talked about that. Let's talk a little bit about absolute value, and I'm probably gonna have to make one more video here, so it's not a problem. So let's talk about absolute value right quick. I think I had made another video, but for whatever reason I had a few audio problems. So what you want to do, talking about absolute value, let's just go to a clean page here. Absolute value. The two type absolute value problems you may run into are a problem like this. So this is absolute value. Okay, and in this review, these reviews are kind of random, guys. As I think about stuff that might be on the test, you know, that are just good, solid, basic problems, just kind of created some or took some out of the book. So what we have here is absolute 2x subtract 1, and that's going to be less than 5, right? And the question is, how do you do this problem? This is a less than. So when I see less than, I'm thinking about less than and. It's an and condition. So what do we have here? 2x subtract 1 is less than 5, and you make it less than -5 right there like that. So then you work both sides or all sides of it, all parts. You end up with what? -4 less than 2x is less than 6. Divide by 2. So you end up having -2. X is less than, greater than -2, but less than 3. All right, that's what you end up with. And if you had to graph it, that's going to go from -2 to 3, like so. All right, that's the less than version. And I'll pick up with greater than, the greater than version in the next clip.